Hi, this session is on division and we are dividing numbers with decimal answers. So we have learned that when we have a remainder, we no longer write, for example, remainder 2. We now know how to turn this and use this to find out what the actual decimal is. Now let's just recap on on some things we have learned. Now if I have 4 divided by 2, now we know 4 divided by 2 is simply 2. But we learned that division can be written in fraction form. So this can also be written as 4 divided by 2. And we know the line here, which we call the vinculum, this also means division. So we can say 4 over 2, or we can say 4 divided by 2. These two things are the exact same thing. So that will equal 2, and 4 over 2 will also equal 2. Now sometimes when we divide numbers, we can end up with a remainder or a decimal. Now if I have 1, so for our second example, if I have 1 divided by 2, and I can write this as 1 over 2, we can see that we have a half. Now we know that a half as a decimal is what? We know it's 0.5. You can use the calculator if you need to, but we know that 1 divided by 2, or a half, is just 0.5 as a decimal. But how do we get this 0.5? Well, we have learned how to set up our algorithm for division, and that is we set up our what we call our bridge, and the number on top, if you ever forget, the number on top always falls down and goes under the bridge. So the 1 will be under this bridge here, the 2 on the outside, and we also learned that you must start by placing a decimal. Okay, so make the decimal visible. We know every number, for example, if I wrote the number 8 up here, I can also write 8 like this, 8.0 if I wanted to. It's still 8. So we put a decimal after the 1 and also straight above it to set up our answer above on top. And let's add some zeros to start us off, because we will need these zeros if we have any remainders. So to show how a half is 0.5 without a calculator, let's start dividing. So can 2 fit into 1? Can 2 go into 1? No, it can't. So we put a 0 there because we haven't gotten a number. We haven't used this 1 yet, and instead of writing remainder 1, we now carry the 1 on the 0, and we have the number 10. Now, can 2 go into 10? Well, 2 can go into 10 5 times evenly, and there's no remainder. So we stop there. If we end up with no remainders, then we just stop. And this decimal here is 0.5. And we know a half is 0.5. And this is how we can prove that it's the case, and prove that a calculator is actually working it out this way as well. Now sometimes we get answers where our decimal never ends, and a key word for that is infinite. Just like Toy Story, to infinity and beyond, infinite means it never ends. For example, if I have a third, or 1 divided by 3, and I put this in my calculator, I end up with 0. And the calculator shows 3, 3, 3, 3, 3, and this actually will never, ever, ever end. It'll go on forever, and so we say it's infinite. It never ends. And now some calculators may round it off at the end. You might see a 4 on your calculator. That 4 actually isn't part of the answer because your calculator has rounded it off. So it depends on what model you have, so just keep that in mind. If you have a 4, technically there shouldn't be a 4. It just goes on forever. Now with some decimals, there's a pattern that we can find. For example, with a third, what is the number that's repeating itself? We can see it's a 3. 3 keeps repeating itself, and so there's a pattern. If I gave you another example, if I had, for example, that's example 1. So example 2, if I have 2.7979, and I'll do my 3 little dots here saying this is going on forever and ever, what's my pattern here? Well, I can see my pattern is 7, 9, 7, 9. So whenever we divide numbers, like 1 divided by 3, and the decimal is infinite, so it never ends, there will be a pattern somewhere. Every fraction, or whenever we divide two whole numbers, there is always a pattern. Sometimes the pattern is a quick one, like 7979 or 333. Sometimes the pattern can take a while to find. So let's try a third one. So with the third one, what pattern do you see? So we've got 2 points, so we're looking at the pattern in the decimal part. So don't worry about the whole number, look at the decimal part. What's the pattern that you see? Well, we can see that the pattern is, well, 1, 2, 3, 7. 1, 2, 3, 7. And these dots here are saying it'll keep going forever and ever and ever. 1, 2, 3, 7. And it'll never stop. So when we have decimals like this and there's a pattern, we can actually write them in a shorter way, because as you can see, this takes up so much space, and we've come up with a way to write it that's a bit more simple. And so the first one, instead of writing 0.3333 and then these dots, we can write it like this. 0.3, because 3 is the number in our pattern. When you have one number in your pattern, you put a dot on top. And that's it. That dot on top is saying that the 3 is going to repeat itself forever and ever and ever. With the second one, we've got 2.797979. So the pattern in this one, we've got 2 point, the numbers in the pattern are 7 and 9. And because we have more than one number, instead of a dot, what we do is we use a dash, like a line, covering both of these numbers, saying this answer is actually 797979 as its decimal. And so number 3, because we have 4 numbers in our pattern, 1, 2, 3, and 7, we have 2 point, write down the numbers in the pattern, 1, 2, 3, and 7, only write them once, and we'll do a dash over those numbers, saying 1, 2, 3, and 7 will repeat itself forever and ever and ever. Okay, so remember, you use a little dot for one number, but if there's more than one number in the pattern, then you do a line or a dash above the numbers and only write the numbers once. So 1, 2, 3, 7, they're the numbers in my pattern, so the line covers them all. So now that we know how to write our final answer when we have a infinite decimal that has a pattern, let's try and divide this question here. So we've got 2 divided by 9. So I'll get my bridge ready, and 2 falls down and goes under the bridge, 9 on the outside. Our next step is get our decimals ready, make them visible, and add some zeros on the bottom. I'll put 3 to start us off. Now, let's get started. So 9 into 2, can it go into 2? No, so we put a 0 here. We haven't used a 2 yet, so we put 2 on the other 0. So now 9 into 20. Well, I know that 9 times 2 is 18. So 9 can fit into 20 twice, 2 times. Now remainder would be, so 18, 19, 20. Remainder is 2. Okay, so I've got 20 again. So 9 into 20 can fit, well, 2 times. I get 18, so remainder 2. Okay, I've got 20 again. 9 into 20 goes 2 times. This gives me 18. And the remainder will be 2 again. Now, what do you notice happening? Is this ever going to stop? No, it won't. This decimal is infinite. It will never stop, but there is a pattern. And what's our pattern? Well, the number repeating itself, there's one number, and that is 2. So our final answer, we can stop here now, we found the pattern, will be 0 point. I've got only one number in my pattern, which is 2. So because there's one number, I'll put a dot on top. And that dot saying 2 will repeat itself forever and ever and ever. So try and have a go at this next question and see how you go. So just pause it, but I'll get started. So once again, we get our bridge ready. 2 will fall down and go under the bridge, and 3 on the outside. Get our decimals ready, make them visible, and add some zeros. We'll have 3 to start us off. So now we simply start dividing. Can 3 go into 2? No, it can't. So we put a 0 up there. We haven't used a 2 yet, so it's carried on to that next 0. Now 3 into 20. Well, can 3 fit into 20? Yes, it can. I know that 3 times 6 is 18. So I'll put a 6 up there. And remainder, well, 2. Once again, 3 into 20 goes 6 times, remainder 2. And what do you notice? That's the pattern will never stop. So we can keep on going forever, but I think we've got better things to do. So our final answer will be 0 point. Once again, there's one number in our pattern, and it's a 6. So we put a dot on top saying 6 is actually repeating itself forever. Now, with this one, our next question, you might find it a little bit more challenging, not because it's really harder, only because the pattern may take longer for you to find. So I want you to have a go at this first. So just pause it, but I'll get started. So get our bridge ready. I'll do a longer bridge for this one. All right, so 3 falls down and goes under the bridge, and 7 on the outside. Once again, get our decimal ready, and we'll add some zeros. Now I'm going to add a few extra zeros because I sort of already know what the answer will be like. But it doesn't matter if you don't add all the zeros now, you can add it later anyway. So let's get started. 7 into 3, can it fit? Once again, it can't, so we have 0, no whole numbers there. We haven't used a 3, so we carried on to the 30. Now 7 into 30, can fit 4 times, because I know 7 times 4 is 28. So 4 times, so 28, so remainder 2. So now I've got 20 here. So 7 into 20, well, I know 7 times 2 is 14, so that can fit 2 times. And the remainder will be 6. So 6 can go on to the next 0. 7 into 60. Well, I know 7 times 8 is 56, so that can fit in 8 times. And the remainder will be 4. 7 into 40. Now, is there a pattern appearing yet? Do we see numbers repeating themselves? No, so we'll keep going. 7 into 40. Well, I know 7 times 5 is 35, so it can fit 5 times, and the remainder is 5. 7 into 50 now. So I still can't see a pattern, so I'll keep going. So 7 into 50, well, I know that 7 times 7 is 49, so that can fit 7 times. So I've actually got to add some more zeros. Now, I might not have enough room, but we'll see how we go. So 7 into 50 goes 49. It can fit is 49. So we have remainder 1. Still no pattern. So 7 into 10. 7 into 10 can fit once. Okay. So what I'm going to do, I'm just going to rewrite this down here so we have more room. So I've just rewritten the exact same thing down here, so I have some more room. So I'll just stop here for a second. So 7 to 10 can go once, okay? And I've got another 0 here that I was put in, and the remainder is then 3. So at this stage, I've got 0.428571. I still can't see a pattern, but I've noticed now I've got a 3 here, and I've started off with a 3 over here as a remainder. So I might start seeing a pattern. So 7 into 30, well, 7 times 4, once again, is 28. So it can fit 4 times, and the remainder is 2. And 7 into 20, well, that can fit twice, because 7 times 2 is 14. And I'll stop there because I can see what's happening. I'm starting to get the same numbers, 4, 2, 4, 2. And once you start seeing that, you can actually stop, because you know your pattern is this, 4, 2, 8, 5, 7, 1. 4, 2, 8, 5, 7, 1. And if you wanted to keep going, to prove that, keep going. So my final answer will be 0 point, the numbers in my pattern are 4, 2, 8, 5, 7, 1. Okay, and I'll do a line all over these, or a dash, saying these numbers will keep repeating themselves forever and ever. So now here's a question that you can try on your own, and double check your answer with a calculator. Thank you.